Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of writing systems of equations, specifically how we can do it if given two tables of values, and we'll do it in 5 minutes or less. So we've got two different lines represented here, and if we were to graph them, they would intersect at one point, and we could take that point, plug it into each equation in standard or slope-intercept form, and it would be a true statement. We don't have any equations though, so let's start by line 1. Let's start by finding the slope. Remember, my slope is change in y over the change in x. So let's just use this. It's my x1, my x2, y1, y2. And so 4.75 minus 3.25, right? And that's going to give me 7 minus 1. So that m here is going to be 1.5 over 6. Kind of weird to have a decimal in there. But you know, 1.5 doubled makes 3, 3 doubled makes 6. So really, that's just 1/4. Or, since we're dealing with decimals, let's just go ahead and make that 0.25. Now we're going to need our point slope form. Y minus y1 equals m x minus x1, and let's just use that right there. So y minus 3.25, it's my y1. My x is going to be 1. That slope, remember, I put that back into a decimal form, so it's just going to be x minus that 1 right there. So it's going to be y minus 3.25 equals, let's distribute this out, 0.25x minus 0.25. Now all I need to do is just add 3.25 to both sides. 3.25. Let's see if we can get that written correctly. There we go. 3.25. So that cancels out. So slope-intercept form, y equals 0.25x. That's just going to be plus 3. I could also write that in standard form if I wanted to, but this would be our slope-intercept form. Let's do the same thing over here for line 2. We need to find the slope first. So remember, that's change in y over the change in x. And let's pick some x and y coordinates that are going to work for us. Let's just do that right there. y1, y2, x1, x2. Always good to label them. All right, so y2 is negative 0.5 minus negative 7.5. That's going to end up being a positive. And then I've got, let's see, x2, that's just 1 minus negative 1. All right. So we've got on the top, that's going to be 0.5 negative 0.5 plus 7.5. That's just 7. That's just two positives. All right, so that's 7/2. So m equals 7/2. Now let's plug this into our point slope. Y minus y1 equals my m, x minus x1. And you know what? Let's use that last point because there's no decimals there. So y minus 31 equals my slope of 7/2. X minus, and then my x1 is 10. So if we want to distribute this out, that's going to be 7/2 x minus, that's just going to be 5, 35. And then if I wanted to put it into slope-intercept form, add 31 to both sides, right? Y equals, we can say 7/2. Since the other one's in a decimal, we'll just make that a decimal, 3.5x, and that's going to be minus 4. So what I have here are two equations, one representing each line in slope-intercept form. If I were to plot those, right, I would find an intersection point. And at that intersection point, whatever that x and y is at that intersection point, I could actually plug it into each equation, and it would generate true statements, and that would be the solution of intersecting lines.